Well, hi, good morning. Thanks so much for joining me in my shop. So, today what I'm going to do is I'm going to focus on an issue that I stumbled on very early on when I was looking at this radio. I've never done anything about it. A number of you have commented on it. So, although I considered it to be a very low priority or low possibility of being a problem, especially in terms of hum, at this point I think I really need to eliminate the situation or correct the situation before I go any further, just in case it is the source of the hum. Now, so what I'm talking about is small filter capacitors, very common in radios, that are put across the power line. You know, they're either put, this is the power cord here, they're either put right across the line, or sometimes there's some tricks played with them. Sometimes you put two capacitors in series across the line and you take the center connection point and ground it. And that's how this radio is actually supposed to be. So what I noticed is it's quite clear in the schematic. Let's take a look. Here's what we want to look at. Power supply over here. So what this shows is here's the 110 volts coming in from the plug through the on-off switch. And then these are three selectors for three different line voltages: high, low, and medium. High, medium, and low. And here we have a takeoff to go to a dynamic speaker, which I believe this would power the electromagnet in the speaker with 120 volts, but I don't have that in this radio, so these connections don't exist. We come along here, and this is what I'm talking about right here. Here you see basically two capacitors in series put across the power line, and the center point is chassis grounded. That's what that indicates. Or does it? Is that what that really indicates? Look, it's a style of ground indicator. It looks a little like an arrowhead. Very familiar. I'm sure you've seen it. Every other ground point in this radio is shown as a chassis ground. That's why I did nothing about this last time around. I got paralyzed at this point. I don't know what they mean by that. Do they mean this is supposed to go back to the chassis? Or are they actually suggesting this goes out to a ground rod? I don't know. I don't know what to think of this. Could this really influence the hum in the radio? If this is connected to the chassis, if it's supposed to be connected to the chassis, then maybe so. If it's not there, maybe it's, with it missing, something is not happening, and this is why a hum is occurring. On the other hand, if this goes to a ground rod, wow. Now the situation here, I have to go a little further. I have to consider my house. Here's my house out here on the schematic. So plug this into an outlet. No, I don't plug it right into an outlet in my house. It's plugged into a plug on my bench, which goes to a transformer sitting here, an isolation transformer. So if we look at the primary side of the isolation transformer, just use your imagination. That's coming from the ordinary power wires in my house. One wire is 120 volts above ground, and the other wire is tied to earth. But that's on the primary side of this transformer. That's what this radio is thinking it's being plugged into. Does that somehow influence this whole deal? I've got this isolation transformer, and that's why the radio hums. Boy, I have a really hard time imagining that to be the case. But these are all factors when you think about this. Especially if we just go back to what I was talking about. If there's no isolation transformer, then one grounded leg of the power system is connected to one of these two wires through the plug. That's not the way mine is done here. Mine is floating. This is all floating. That's the word people like to use for this. Ungrounded. And with this missing, there's nothing. There is nothing tying this circuit all the way back to the secondary of my isolation transformer There's nothing tying it to earth except a little bit of capacitance in the isolation transformer itself. There's going to be a little bit of capacitance between the primary and the secondary. So these are the reasons why I kind of stayed away from this after observing it very early on. But I think now I have to experiment with this. So you can see there's quite a few angles in this. One of the easiest ones is I should plug the radio into a regular outlet before I do anything anymore with it. Plug it in, see what it does. Is it any different than running on the isolation transformer? I'd be surprised if it was. But I think I've got to eliminate these things. Or perhaps I'm chasing something in this radio that is related to literally how the radio is plugged in, and I'll never ever get to it by fooling around in the rest of the radio circuitry. So unfortunately, the process of elimination, there's a lot of things that need to be eliminated
in what I think is an excellent direction. I'm starting to use a piece of software called, oh my God, what is it called? It's called Shot something.
I'll think of it in a minute anyway. And that's what I'm starting to learn to use for software editing. So this video you're watching will be the first one I put through a whole new work process. See, one of the things that goes on with videos here, if you're going to do this kind of thing, is handling the big video files. If you're going to go through an edit phase, and I do very little editing, but I still do some, I tie together individual segments of video into one long segment, chop out a few pieces that are just horrible for some reason, things like that, just a little bit of editing. If you're going to do that stage, there's a large, how can I put it, a complicated workflow process starts appearing in front of you as you try to transfer files and do other stuff. These big video files. And a lot of time can be wasted if things aren't done right. So anyway, we won't talk about that anymore. Let's see. I think the first thing we should do is inspect the power line here really carefully. And we'll see what... we'll make absolutely sure there's no capacitor in here. Scratching sound in the background is my little cat. There we go. So what I really want to follow now is the power cord up here. And I want to look and just convince myself there is no capacitor in here. So you can see this goes up. So that's the line voltage selection, the 3 selectors. Now it could be a capacitor hidden up in here. I've got autofocus on. That's going to present a bit of a problem, but I certainly... Looking at how these wires are soldered, and I think we're talking about a non-conductive surface up here. This stuff is on. I'll have to turn off the autofocus here on my camera too, but so you see there's a large non-conductive block, and you can see rivets holding the block, this piece here, holding the block to the radio. It's also riveted to a non-conductive surface here too, so riveting should not introduce any kind of issue at all. Likewise, or let me get rid of the autofocus here. Hang on one second. Just calling up the camera control box. There. So that black material is non-conductive. So when you see little solder spills and stuff like that, it doesn't matter. Same thing down in here. It's all non-conductive. So no sign of a capacitor. Now let's follow. So these wires, which look like just ordinary power wires that have been pulled apart, like well, they disappear. Who knows what evil lurks in these dark corridors? I'm not really sure what I'm even looking at in there. You know, that does raise another question. This radio has had its transformer apparently replaced or rebuilt, or something big time was done to its power transformer. Right? That's the guy here held together by wood, which I've also left alone on the basis that I can probably only make the situation worse. It really looks like a rewound transformer. It's really what it looks like. You know, that could be the cause of the hum, and it could be I can never ever solve it. There's just I'm nowhere near to solving it with all the stuff I'm doing. Okay, back to looking for capacitor. Come down this is the wire coming in right from the cord here. Right from the cord. Goes down, it leaves. Comes around to the switch here. Back from the switch. Tape connector to this wire. Where's it going? Oh, here it is up here. That's it there. It's kind of got around underneath everything. Pretty sure it's connecting right onto here. Yeah, so when I wiggle the wire, I'm saying to myself, so where does the end have to be for the wire to move the way it's moving? And it's pretty much got to be soldered here. So no sign of a capacitor. There's that horribly cracked wire that I'm a little worried about, this one here. Wow, a short on that could cause some serious trouble. I think this is leads going to heaters from the transformer through these resistors here, these wire wound resistors. Short on that might burn one of these guys up. Wow, you got to keep an eye on that wire. That's going to have to be changed. Oh my gosh. What's going on here? It's a little strange. Okay, hang on. The distractions. The distractions have arrived. Okay, look at this screw here. Now that screw is going through into metal. That's metal back here. It's almost certainly a machine screw. Here we can see this one much better. Machine screw. Standoff down below. Almost certainly non-conductive. This material right here, this is non-conductive. So is there anything electrically contacting that? No, no, no. Close, but no. Over here. See the rivet. The rivet is the electrical connection point between the wire and the terminal here. The screw is just mechanically holding this thing in place. Maybe look at this one. Same boat screws out here. Okay, screw is... Nothing's touching the screw, but it's pretty close. And this last one. Screw is free and clear. Come down. Not the last one. The screw is clear here. Oh. Oh. What's happening here? So how is this held in place? How is this resistor held down? It doesn't have the screws on the end. Instead, it's got connections. And look at this one. Okay, so this one, assumably the screw is going down into the metal plate here. And it looks like no wire's ever been in this. I've been through this once already, but this has to be the connection to the chassis. It's not going anywhere else. There's no lead wire coming off this. Connection to the chassis like that. Okay, let's take a look at the schematic and is this done correctly? Okay, so where we're looking now, we're looking right here or here. Okay, so right to the chassis. This other one is also connected to the chassis. Must be done with a wire since the screw's not there. So what they've done is they've just made the connection simply through the support screw on one of them. That's now smartened up here, and I have this diagram here, which I should have been looking at yesterday instead of trying to think my way through things. Look at that. Look at it. It's showing exactly the same way with the open connector there. See, these must have come from the manufacturer with these two connectors ready to accept wires. And what they've done in this radio is they just simply made the ground connection through the screw. So this is all appropriate. That didn't help much. That's 110. So 110. So this is... I did get it right. 110 is here. It's the shared cathode resistor between the line that feeds tubes, the tube in question, and also feeds the 3 RF tubes. You know, when I'm only running one tube in here, that reduces the amount of cathode to plate current to a quarter of what it might be with all 4 tubes in there. A quarter of the current is going to drop the bias quite a bit. In other words, this radio won't bias properly unless all 4 tubes are in place. Huh. And these resistors are also part of the cathode arrangement. Cathode resistor arrangement. Are they not? The plate current is drawn into this resistor through both of these. How this makes the tube impervious to the 60 cycle hum in the filament it's not clear to me. What I imagine, it's another thing that is an insolvable problem with this radio, is the heater is being powered by 60 cycle AC, and it's a direct cathode. In other words, there's no cathode. Like in this tube, there's another cathode right here. This cathode is heated by the heater. So you can imagine this heater is pulsing with heat 60 times a second as the 60 cycles goes back and forth through it. It may not be much. There's thermal inertia in thermal. It may not be much. The temperature variation on the heater may be a tiniest amount from the variation in the power going through it, 60 times a second. In this tube, the heat is then thrown into the cathode here. The cathode is another chunk of metal now being heated indirectly by this. Its temperature variation is probably much less. The 60 cycle pulsing of the heater here, it's going to be greatly reduced by the addition of the metal of the cathode. Now this tube, of course, there's no cathode. So the filament has got to be pulsing at 60 cycles a second to some degree. To what degree, I don't know. It's got to be some degree. Now these tubes would all be the same, these ones over here, except if they do produce a 60 cycle hum from that, it can't make it through these air core RF transformers. So even if these guys are actually humming along at 60 cycles, it's just not going to make it through the radio. So that's another factor. I could just simply be fighting heater hum here that can never ever be gotten rid of. I guess, another way to look at this is ultimately what you're listening to when you listen to the radio is signal to noise ratio. In this case, the hum, the signal to hum ratio. If the signal is weak, you will tend to turn the volume up to compensate for the weak signal from the radio station you're trying to listen to. And as you turn it up, you're going to get more hum out of this. Is that true? Can I turn up the volume, get more hum? Not on this radio. Not on this radio. No. This radio, the volume control, oddly enough, is just controlled by the level of signal coming in the front end. So the hum would be consistent all the time, regardless. How can I prove to myself that the hum I'm chasing is really coming from the heater here and cannot be resolved? You know how? Power the heater with DC. That's easier said than done, because it's not this tube. I could do it easy, just power the heater with DC, separate source. But this one, the heater itself is part of the actual radio circuitry in here. It's kind of weird how they've shown this inside the tube. And they got the heater here, they got the filament over there, and they got the plate over there. It's kind of an odd way of showing it, but okay. For sure, if I pull this out, the hum disappears entirely. Likewise, if I pull this plug out here that separates the radio from the power supply, the hum disappears entirely. That tells me no hum from the power supply. This is what it suggests to me anyway. No hum from the power supply of any significance. No hum in the output tubes of any significance. The hum is coming from back here, and I know from earlier experiments it's coming right in here. you know what I'm doing? I'm convincing myself that the hum cannot be done away with, and I really should be concentrating on improving the signal coming through the radio. The hum is the hum. Okay, getting back to what I really wanted to do to start with, which is fiddle around with this. Again, I don't know what to do with this. I'm really a little anxious about putting in these capacitors and then tying this to the chassis. If they wanted this tied to the chassis, this would have a chassis symbol on it. Why wouldn't it? This also, this ground point, if it's an external ground point, like to a water pipe or something of that sort, then there's a terminal, there would be a terminal on the radio for hooking a wire up to, a ground terminal. Quite distinct, and it would be on the power supply chassis. Ground terminal. Let's go looking for that. Ground terminal. So this is the back of the radio where you see the terminals for the speaker. So if I were a ground terminal, I'd be sitting back here. Another possibility is it's on the it's on here, and we would, well, it doesn't make a lot of sense. Possibilities up on the top. Let's take a look at the top here. See what we can see. A bit of a close inspection. I think if there was a terminal, I'd know it by now, because I've been fiddling around with this long enough. I would have seen it. It would be maybe along this apron here. Where else would I would be a wire hanging out. That's a little less likely. There would be a hole on the back panel somewhere for me. What's that? That's a hole. There's a hole. Okay, if I put a hole for a ground wire to come out on the other side, would be the place I would want to connect it, which of course is the two capacitors, which I never found. I never found the two capacitors. I never found anything. I never found anything. No two capacitors and no ground point. You know, usually a radio of this age really needs a ground connection on the antenna circuit. They generally don't work all that well without them. Let's go back. Let's see how the antenna's done here. The antenna. Oh, look at that. 6. Those both look like terminals. Now, there's an antenna wire hanging out of this radio. There is no terminal. Assumably it's that. And there is no wire like this, and this is tied back to the chassis. 6. What is 6? 6. Let's say 32. External condenser. Tiny, 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 tiny. Tiny, 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 so it can pass the RF signal but not pass any AC, any 60 cycle AC, give you a shock. Maybe that's why it's tiny, tiny, tiny capacitor there. I don't know. I really don't see. This is, we're looking at a different version of the schematic here. Here's the other version. Identical in here. 4 dynamic speaker. It's not identical. Somebody else drew this. This is different. It's the same symbol here. Okay. that's where I be. I be at the point where I think this hum is undefeatable. And I'm really chasing the wrong thing entirely. Let's play the radio for a minute here and hear the hum. And make a judgment as to whether that hum is actually tolerable or not. And this is tricky because I haven't got much radio oomph coming out of this radio. I put all these tubes back in. Doesn't seem to make much difference anyway. Very interesting inside that tube. This is the detector tube. See at the bottom the two leads coming up from the base of the tube where they hook up to the heater. The heater is very fine wire, and around the heater is a white sleeve. And then can't really see it. Oop. Up in there is a grid. I think you can see the lead going up to the grid. And then the outside is the plate, which we usually think of as a solid piece of material. But in this tube, it's a piece of screen. Huh. Okay. Pop this guy back in. Okay, all the tubes are in. So the purpose of this is to figure out if, in fact, the hum level is low enough to be just ignored. I don't know if I'm going to be able to resolve that. I'm going to put an antenna on. Good, the outdoor antenna is connected. Okay, power on. Just before I do that, anything out of sorts here? No. Okay, there's the hum. I can put full power onto that. So you know, that's a pretty strong hum to me. Let's get some sound coming here. Too soon. Gotta let the thing warm up. Gotta be patient here. Yeah, by the way, the crackle's next on my list of things to try to really honker down on. It's an interesting observation here that all that crackling didn't come until I believe this tube started operating. The crackle's either from here or one of these or some other circuit element. listening very carefully to the hum, just the hum part. It's not perfectly stable. Volume makes no difference, but then the volume is just padding down the antenna signal, so I wouldn't expect it to make much difference in the radio other than drowning out or eliminating the antenna signal. Listen to that big pop there, eh? Wow. Okay, now these radios, generally, in my experiences, when they're loud. They produce lots of volume. There's no shortage of volume in this thing. The hum is definitely annoying, though. I mean, that's a pretty darn distinct hum. If you wanted to play the program material, if we could receive a station here, this thing was actually working well, tune in a station, and you want to make the station loud enough that you don't hear the hum, that thing's going to be blaring in your home. So just by thinking about that, it seems to me this hum is way beyond what would be normally tolerable on a radio like this. Pretty hard to hear the hum during that little deal, but again, you're watching a video, so the volume's not, you're not hearing it in a room like I am. That was pretty loud. That was turned up pretty loud. You wouldn't want to listen to this radio at that volume all the time. So that's definitely the antenna signal. I just turned it down with the volume control. Another thing to think about is, even though all we're hearing is a bunch of junky noise, as far as a radio is concerned, that's another radio station. And when you hear the volume of the noise coming out of the speaker, even though it's not a radio station, the noise is producing a high volume, and you know what? The hum is really quite tolerable at that point. You don't hear it at all. So if this thing was receiving a radio station signal strong, there is a good chance that the hum would become a secondary factor. And the fact is, no one's going to sit and listen to this radio for hours, and it's not going to happen. This is going to be another demonstration radio. Turn it on, look at that, it works. Wow, that's what this is going to end up being. So on that basis too, hum is fairly tolerable. So what we're left with now, I just don't think I can overcome the hum at this point, so I'm gonna move on. I'm gonna turn up my microphone. I'm gonna move on. I'm gonna go after the crackle next time, and if I can figure out the crackle, that'd be great. Where'd the crackle go? Where'd the crackle go? Come back to me, crackle. There's a little bit there. Try hunting down the crackle a little bit, and from there it's back to radio sensitivity, and then that's pretty much the end of the road for me. I think that's kind of how this is going to go. So crackle, actually the snap, crackle, pop, do all three of those, and then the radio sensitivity, and then that's it. I don't know what to think. There we go. Okay, alrighty. Wow, I'm just beating my brains out with this radio. I'd say 1 in every 25 things that come through my shop, I end up beating my brains out on it. Thank you for the other 24. Hey, see you on the next video, and have a great day or evening.